We are on, so we can go ahead and begin.
Okay.
So I'll start with number 1. I'll read through the study at first. A study by the National Association of Realtors reported in 2004 that second home sales accounted for more than a third of residential real estate transactions. According to the report, the average age of a person buying a second home as an investment rental property was 47 years. A real estate agent wants to estimate the average of those buying investment properties in his area. He randomly selects 15 of his clients who purchased an investment property and obtains the data shown. What are the requirements for creating a 95% confidence T-interval? So I put that there is a random sample from the population taken, and that X bar is normally distributed.
Yep.
Very good. Okay, so I can do number 2.
Okay.
It says, with data above, create a 95% confidence interval to estimate the mean age of all clients who buy an estimate property. Input the numbers you computed in number 7 of part 1 into the confidence interval formula. Show your work below. The T-score for a 95% confidence interval from the T-distribution with 14 degrees of freedom is 2.1448. Make sure you do not round or over-round while making your calculations. And so I got the sample mean is 46.7333, and the sample standard deviation is 8082745. So when I plug those numbers in, I get a 41.845 and 51.2 or 622.
Yep. And then essentially, we have that same confidence interval for number 4A as well, which threw me off at first because I was like, okay, is this asking something different? But they just reworded it.
Well, the first time they wanted you to actually work through the formula,
right?
Yeah.
To get the answer, and then you could compute it using the software, and it turns out to be the same thing.
Mm-hmm.
So now, did you say, Ruth, that your sample standard deviation was 8.0 something? What did you say?
8.82745.
Oh, okay. Okay. So it rounds up to 8.3. I thought you said 8.0 something, so.
Oh, yeah. Okay, so that's what I got.
Good.
Shall we do the next one?
Yeah, sure.
Okay, so I have to tell you, I was just thoroughly, I thought I was doing well on the last one, but at the Tuesday's homework, and then when I got to today's homework, I was completely off. So I'm probably going to make some mistakes, so help me out if you wouldn't mind. Now create
Oh, you were.
So I just want to start with the formula because I think it's more out of the formula, if that's okay. Mind? Is that all right?
Yeah, go ahead. You might want to turn towards the mic when you're speaking, because for some reason when you turn your head a little bit, the sound drops off. At least for me. I'm not sure if it's dropping off for the other two.
Yeah.
I can hardly hear you.
You can? Oh, shoot. And my volume's all the way up. Can you hear me now?
I can hear you whenever you're turned towards the computer. I can hear you really well, but sometimes when you turn away, for whatever reason, the sound drops for me.
Okay. I will turn towards the computer. So so for the formula we have x bar, but we're replacing t.
Yeah, see, I'll start with the
Sample standard deviation over the n, square root of n, correct?
Yeah, so just making sure that because you went out for a second. I mean, the formula that it sounded like you were saying was the x bar plus or minus t times s over or divided by the square root of n.
Perfect. Okay. So then we take the. Did you guys plug in the 99% into the student's t probabilities applet?
No.
No. You can use the applet. You can use the applet. You can use the applet to show you what the shape would be, but they don't recommend that you use the applet to actually get the p value.
Okay. So maybe somebody else should do this one because I am so confused. Sorry.
So we don't have to worry about the 99% right here because it gives us the t distribution, the t-score for the t distribution. Okay. So it already gives us that, which is 2.9768. So that's what we plug in there for the t.
Okay. 2.9768, and then the sample?
So, yeah, so it would be 46.7333, and then you would do plus or minus 2.9768 times 8.82745 divided by the square root of 15.
Okay, so the square root of 15. 8730. I like the chart. Oh. Minus the 2.
I mean, for some reason it keeps dropping in and out, so we'll catch like little bits of what you're saying.
Sorry, I'm losing my voice a little bit too, and that doesn't help.
No, it's never good when you're sick at the same time. So if you take the 8.82745 and divide that by the square root of 15, you should get 2.279237789 on your calculator.
$2.8311.
2.279.
So it was 8.827.
Oh, sorry. 8.82745 divided by the square root of 15.
Right. And I got a totally different answer.
I got the same as Ruth did.
Equals, okay, 2.2792. I must have entered it.
Yeah.
Okay.
Okay. And then you can times that by the t-score, which is the 2.9768.
We times that?
Yes.
Yeah, because that's the formula t times s.
Oh, I was doing a completely different formula. Oh, I see. T equals x bar minus mu is what I was doing.
You should be doing the x bar plus or minus t.
Okay, times s over the square root of n.
Yes. Yeah, that's right.
So you were using the formula to get the t-score, but they've given us the t-score, so we can use the other formula for the confidence interval.
Okay, so I got 6.7830.
Great.
Yep.
Okay, then with that you can take that number and you can when you plus and minus it, you'll get the two numbers. The lower and the upper numbers that you need.
And you subtract that from what?
You'll subtract it from 46.7333.
How did you get the 47.6333?
Yeah, 46.7.
Oh, how did you get that? 46.7.
In the very first part, it asked us to take the 15 numbers at the first part of part 2 and plug those into either SPSS or Excel, or you could use your calculator to add all of those numbers up and divide them by 15, and that's how you get your 46.7333. To get the sample standard deviation, you do need to do SPSS or Excel so that you can get the 8.82745.
Okay. So then, with the plus or minus, the low would be 39.9 and the higher side would be 53.5.
Yep.
Yeah.
Yep, that's it.
Good job. Yep.
Excellent.
Thank you. Sorry.
No, you're welcome.
That's what we learn.
That's right. It cements it in our brains.
Yeah, no kidding. So, number 4, unless you want to take that, Karina.
Sure.
I don't want to jump over you.
No, you're great. So then the confidence interval is 41.845 and 51.622.
Good. So on these minute, we just had to plug in on the SPSS or Excel.
Okay.
And that is how I like it.
Yeah, me too.
Made it so much easier.
B, yeah. So for B, I got 39.9 and 53.5. I just rounded up.
Yeah.
Drop those off.
Very good.
Did you want me to do number 5?
Yeah.
Sure.
So how does the margin of error of the 95% confidence interval compare to the 99% interval? And I put the margin of error for the confidence interval is less a 95% confidence level than the 99%.
Okay. Yep, that's what I got.
Yep. Me too.
And then the null is 47. And then the alternative hypothesis does not equal 47.
Yes.
Yep.
Okay, and then B says compute the test statistic. Let's see, first compute it by using the formula and showing your work below, then check this test statistic by inputting the data into the software. So to get the test statistic, I did 46.7333 minus 47, which is the sample mean minus the population mean, and I divided that by 8.82745, and that again divided by the square root of 15. So it ended up being a negative 0.2667 divided by 2.279237789, which equals a negative 0.117012.802. Or if you round it, it'd be 1.77 or 0.117, a negative 0.117.
Okay. Yes, that's what I got.
I rounded up and I got a 0.118.
You know, it's interesting.
Negative 0.18.
I was wondering about that because when I watched the video, he did come up with a 0.118. And I couldn't figure out how he kept doing that. But then when he went to check it on the Z-score or on the T-score in the SPSS, it did say a negative 0.117 as opposed to a negative 0.118. But I don't know. I got a negative 0.117012802. So I don't even know how I would round up to 118.
Well, when I did, because I was trying to figure out, so I just rounded up to begin with. I rounded up the 46.73 minus 47 divided by 8.83 with the divided by the square root of 15. So
and that's probably why you would get it right there.
Yeah, and it gave me the negative 0.27 divided by 2.27989, which gave me the 118.
That would make sense. I was wondering how he had arrived to that number, because I mean
yeah,
because that last, which one was it? Oh wait, it was number 2. It said make sure you do not overround while making your calculation. So I left everything in that original format, but that would make a lot of sense.
And that kind of confused me too, but when I plugged it in, SPS, then it dropped off. It dropped it off and just put 46.73. So at that point, I just dropped it off. So
got it.
I don't know if that's how we do it all the time, but that's how I came up with that difference.
Did you get a different number on your for the SPSS? Did that come up with a negative 0.118 for you?
7.
Yeah, I came up with a 7 too. So I'm wondering if hers came up with something different.
I can't remember now, to be honest.
Did
I closed that out because I figured we'd need to do something else.
Yeah.
Did you put it?
I honestly can't remember, but it seemed like it matched up when I checked it.
I see.
So.
See, it's funny too, because when I watched the video, I kept thinking he had to have done something to get the 1118.
Yeah.
But I mean that makes perfect sense, because you're right. I mean that's what it does say on the thing. It doesn't bring out all the extra numbers. Sorry, you were saying something, Karina.
Yeah, I was confused when it said that too, to not over round things. So, but I was wondering, now are we talking about a sample? So do we round it automatically up anyway? Remember how we did that last time?
We did that for the sample size. Because you can't divide the sample size.
Right?
No, because this were just...
Okay.
Blah, blah, blah. Test
statistics.
Yeah. If I could speak English.
Yeah, so I think it's only when we're dealing with, unless they say something different, only when we're dealing with the sample size.
Sample size, okay.
But it's kind of funny though. That's kind of the difference where you don't want to cut it off too soon so that you get all of the decimals or all of the points that you need. But then when you watch some of the videos, they do round it up.
They do round it up, right?
And I think in the last video that I watched, he said something about how the test actually gives you a little bit of a cushion on, if it lets you kind of make a difference of so many points, like decimal points to account for that, is kind of what it sounded like he was saying.
Oh, that's good. I don't remember hearing that, but that's good.
It was right when I was watching that one, the 1118, but I think it might have actually been on the next one when they were doing the sketch, the T distribution, that he had said that.
Oh, okay.
Oh, and that's what I think.
See?
So C then is state the degrees of freedom, so that would be 14.
Yeah.
Can you guys hear me all?
We can. I mean, it kind of goes in and out. Sometimes you'll be talking and you start a conversation and we hear you, and then all of a sudden you drop off and we don't hear you for a while, and then it will pick back up again. So, yeah, it's kind of there and then gone. But we know you're still there. Okay, so D says to sketch the t distribution and shade the area which represents the p-value. So this was the part where you can take the t-score and you can go to the applet and plug in the t-score, but only to get the shape of the t distribution. He had specifically said in the video not to take the p-score or the p-value from the applet itself, but to actually get it from SPSS or from Excel, because it'll be a more accurate p-value. So this is that's the shape that I got. So it just has it has that there, and then it had just a very thin strip in the middle. Is that similar to what you guys got?
Ah.
Yeah, that's what it
Pull
looked
that
like.
up one more time.
Yeah.
Yes. Yes, that's exactly what I got. Yes.
Yeah,
Awesome.
that's what mine looked like. Yeah.
Yay.
I didn't see yours at first, but it sounded like the thin strip in the middle sounded like mine.
Did you see that, Minette?
I did. Thank you.
Okay.
Yeah.
So that's where you can use the applet to go in there and put in the score there. But then
That's what I did.
yeah. But then for E, when it says to use the software to compare the p-value, I guess this would be the difference, because when I typed it in the applet to get the shape, the p-score was 0.9061, whereas when I type it into SPSS, it's 0.908.
Yeah.
5.2. So it says 5.2. So I guess you could round it up if they wanted us to 0.909. But I left it as 9.8.
9.908.
Oh yes,
Yeah.
yes. Say 0.908.
Yeah.
Do you want me to do the next one?
Yeah.
Mm-hmm.
Do you know that they made a
Gario
3?
And I put Phil to
That's what I got. Failed to reject the null.
Yeah.
Yeah, that's what I got too.
Want to get into skins through?
because the picture is bigger than the .0.
Okay, does someone want to take G?
You know what, Kimantro?
So then.
What about the dirt face? What about the dirt face?
Oh, I thought someone else. I was
It
like,
might be
what about the what?
They're watching football over there, so maybe that's what it is.
Yeah, I'm having a hard time hearing you guys.
So there's insufficient evidence.
That's what I have.
Yeah, that's what I
Oh,
said.
it's just
I
not
have
really entertaining.
insufficient evidence to say that the mean of the realtors
Age of the realtors, yeah.
customers is different
Age of
than the
the
national
customers.
average of 47.
Yeah, that's what I put.
You know, Minette, do you have headphones?
I don't.
I'm wondering if that might help.
I do not want Obamacare. I do not want your Obamacare. Are you dumb?
Hold on one second. Jared?
Unnamed.
Jared?
Unnamed. My third is unnamed.
There's a lot of feedback from them and from the show.
Yeah, that's what I'm getting.
Can we move the show into the other room? The football game.
See ya.
What?
We're hearing the football game and James in particular.
No talking.
Okay, thank you guys.
It's kind of hard to watch a game and not cheer, right?
I know. It's like,
Right.
thank you, sweetie.
So are we ready?
I think so.
Okay.
Okay.
Let's go.
Okay, so do you want me to do number 3?
Yes.
One second, I'm just still trying to pull mine up.
Yeah,
Oh,
mine.
okay.
I'm still getting mine up too.
Oh, sorry.
Just making sure I'm pulling up the right thing.
Yeah, me too.
Right?
Okay.
Alright.
Okay, I've got it too.
In previous lessons, we have assumed the population concentration of sigma was known. In this lesson, we are making a conception about sigma, what has changed. One is we assume sigma is 1, or 2 we assume sigma is the same as the mean mu, or we assume, and I'm going to go with C, is unknown. Can you guys hear me?
You
I
kind of
couldn't
went in
hear
and out.
So C,
Okay.
unknown.
That's what I. Yeah.
Yeah, we assume, yeah, Cygnus. So for the null hypothesis is mean equals 8, and the alternative hypothesis is the mean is greater than 8, and the population standard deviation is not known. Becca collects a sample size of 9 and computes the x bar equals 11, and the sample standard deviation is 6. Use the information for 4 through 5. Is the sigma known? That would be no.
Yep.
Kind of felt like that was a trick question. I'm like,
Yeah.
I think it was.
Okay.
So, sigma is known.
Okay.
So now we need to work through this to get it.
Yeah. So I got 1.5. Tell me if that's ridiculously off or.
Okay.
So for this, we set up that t equals x bar minus the mean divided by the standard sample deviation, right?
Yep.
Okay.
Minus 1 equal.
Okay. So
And
11.
the sample size, right?
Yes. Yeah. Divided by the
Oh, well,
sample.
Okay.
6.
9.
Okay.
Two minus 8.
what did you get, Karina?
1.5.
I got 1.5 also.
I got 1.5.
Oh, shit.
Yeah.
I did it
And
wrong.
we only have to round to 1 decimal point.
Yeah.
So, okay, so I must have done it wrong because I got 3.75. So the formula is T equals x bar minus mu divided by s divided by the square root of n.
Mm-hmm.
Yes.
So T equals, and then we take our s instead of x bar. No, x bar 11
Mm-hmm.
minus the s.
So,
No.
11 minus 8.
Oh, 8, that's it. Okay, goes
Which is the mean.
divided by s, which
Uh-huh.
is 6, divided by the square root of n, which is 9.
Yes.
Right.
9, I got 2.3, and 6 divided by 3 is 2. Okay, and then 3 divided by 2 equals 1.5. Got it.
Awesome.
Yay!
Yay.
So this next one we have to put into either Excel or SPSS.
Okay.
Excel instead of SPSS.
I don't think it matters.
I think you'll come up with the same thing either way.
Yeah.
So we just enter all the data, right?
Yeah.
Yeah.
Okay.
Okay. And then alternate 96.
It's not letting me.
Okay. Shoot. Is it not letting you do something?
No, it's not letting me enter the numbers.
Oh, no.
I'm using Excel. My SPSS would never let me in. Now,
Mine's okay. I'm just going to log back in.
Okay. So let me go back to the test here so I can see what they're asking.
Mm-hmm.
Okay, what is...
ST score.
Okay, so X... I have that would be 98.220.
Yes. Yeah.
Awesome.
That's what I got too.
And mine is being really slow pulling up.
It's like right when you need it.
I know. Well, it keeps pulling up the Oreo double stuff that we did earlier.
Oh,
And I can't.
like what?
I tried to log out and log back on, and it still pulled that up again.
Mine was bringing up the euro weight, and I just had to
Right.
open up a whole new file.
That's what I was trying to do, but it wouldn't let me.
Oh no.
Okay.
This was, where am I?
For S, I got 0.9220.
What did you get for X?
I guess it would be 0.22 or 922.
Yeah,
For
I just got 0.922.
Yeah.
0.9.
For X bar, we got 98.220.
Yeah.
And then for S, we got 0.922.
Yeah. And then for the T-score, did everyone get negative 1.843?
Did you work out the T-score?
I just put it in the software like it said.
Are you doing it on Excel?
Yeah.
That's why. That's why. Okay, so what did
What'd
you
you
get
get?
for it? For the SPSS, you actually have to do something different. It doesn't compute it for you like it does on Excel.
Okay. Yeah.
So what did you get?
Negative 1.843.
843.
Yep.
Just looking over real quick. Let's see.
Well, it's in your mind. It's the Philadelphia market manager. Something's not right on that table for it.
Oh my gosh.
So Ruth, how did you open up a new file? Because every time I shut it down and open it back up, it brings the Oreo stuff back up again.
I went up to, once it came up,
Yeah.
I went to File,
Yeah.
New, and Data.
Okay. That's what I tried to do. Okay, maybe this is.
I had to do
Okay,
it
there we
twice
go.
before it let me do it.
Okay, thank you. Yep, the second time. Now it's finally letting me.
Yay!
I was getting so frustrated because I'm like, I can't help you guys at all. I feel. Okay. It might take me a minute. I'm going to type those in now.
Okay.
So, Karina,
Yes.
you're using Excel. So I typed in all of my data and I got a mean of 98.1842105.
Okay.
So, are you talking about for X bar?
Yeah.
Yeah. So I got 98.220.
Yeah. So mine, I wonder why mine is different. I just went over all the numbers. I don't know why.
Okay, I just worked out the T-score by hand, and it's the same as what Karina came up with the Excel.
That's why computers are my friend.
Yeah, and you know, especially if they work for you.
Right?
Okay.
I say, if they work for you, keep them.
Yeah,
If they
Yeah,
don't, you
exactly.
want to toss them.
So for the p-value, I got 0.404.
And that does, I remember, that does come right up in the Excel.
Yeah.
So what did you come up with that again?
0.404.
0.404.
I'll send over the information in just a second.
Yeah, it'd be nice if those numbers came up on the SPSS.
Mm-hmm.
I guess
Yeah,
that's why.
exactly.
Yeah, I guess that's why you need to know how to do both.
After putting in all the information, where do you find the p-value? Because I'm not finding the p-value at all. Standard deviation.
So you have like the box that says one sample t-test. It'll have the t, the df, the p-value, and the confidence interval. Do you have that box coming up?
I don't see that box. Is it on the left?
So did you just click the first tab? The one sample t-test?
Yeah.
And yours just didn't come up. That is bizarre.
Hold on. Let me go back to the Let's click on the top of the one. Hold on.
Huh.
I don't know.
So Karina, I've opened up the Excel,
Mm-hmm.
and I must be doing something wrong.
And we're gonna read in 7 minutes.
Because my mean is off and my p-value is off.
What does your that is I don't understand.
17. Oh, you know what? I don't think I have all of the all of the numbers in. For some reason, they didn't transfer all over.
Yeah, I put them in one by one.
Okay. That changed everything. Okay, that's exactly what I have on this as well. Yay! My computer loves me.
Yay!
Okay, so actually my p-value is 0.0404. So I have an extra 0.
0.404?
I have 0.0404.
What the?
So let me go.
I've got the negative 1.843 for the t-score, and then I've got the 98.220.
What about
S?
S?
S, I got 0.922.
And did you have it set to mu is less than
Yes.
98.6?
Yes.
Sorry.
Okay.
I'm going to put the t-score in the applet and see if it has that extra 0 at the front or not.
Okay. Wisdom.
Interesting. It does have the extra 0 at the front.
Maybe.
0.0, because this one says 0.065.
Maybe I just put it in wrong. Do you want to just where'd you go?
Let's see. So S is 0.922. T-score.
You want to just
Did you get the same T-score then, Ruth?
We got the same t-score, the same mean, the same standard deviation,
But a different p-value?
and a different p-value.
See, I'm getting
Do you
a
want to just
different
screen share with me?
T-score.
What were you saying? Screen share you? Okay, let me do that.
Yeah.
I'm getting a different T-score.
What's your T-score?
Negative 1.472.
Hmm.
Okay.
Did you put in the test value?
The test value?
So if you go into Analyze, go to Compare Means, and the sample t-test, you have to put in the 98.6.
To get the T-score, you are right.
Right, the test value, because I kept messing that up on the assignment.
The T-score I got for that is also a negative 1.843.
Yeah. So
You put in the test value?
Yeah.
So how
Did you put in 98.6?
Yeah.
Yeah.
how did
Here,
you
let me
open
see
up
it.
the actual t-test? Because it
What am I
says
doing wrong?
Did you put less than?
I did not.
how did you open up the
Okay.
actual t-test?
Okay. Can you see mine now?
Let me pull it back
So
up.
this
Where'd
is
you go?
the SPSS.
Yeah.
So this is the test value that I got for in the SPSS.
Let me. No, your
Where do
screen
you
is
put
black.
less than? I didn't see yours, Ruth.
You know what? Do you see me or do you see my screen?
Oh, there it goes. I think I can see it now.
Okay. So when
Hold on.
I went back up to here, so I went
There we
to
go.
Analyze, and I went to Compare Means to the one sample t-test. I put the test value as 98.6.
Did you?
And
Did
then
you
pressed
put less
OK.
than somewhere?
I did not. She's talking about this.
Okay.
Wait, where am I? She's talking about here. So this is the Excel screen. And when you do the Excel screen, you go to here, and it gives you the option. You can do greater than or less than. So I did less than. And then this is the information that I have for that on Excel. So I have the right mean and the right standard deviation and the test score. But see, I do have a 404 in here, but there's a 0 before that 404.
That is so strange.
How did you get to the one sample test?
In SPSS?
No, in Excel spreadsheet.
In the Excel spreadsheet, I'm using the quantitative inference procedures.
Oh. Okay.
And then I just put all of the information on this side of the screen.
So what did you get for the p-value, Minette?
I entered it into the quantitative and that's why I couldn't find the one sample t-test for me.
Well,
after re-entering the data.
I wonder if I put in a number wrong.
Check your degree of freedom, because it should be one less than 20, so it should be 19. So you'll see if you missed a number at least in there. But then I went to here to plug in the negative. Oh wait, less than. So take that away, and that actually brings us close to that 404. But it still has that 0 in the front. So then, if you were to just use the applet as something to kind of check the decimal points, you would have the 0.0327.
Yeah, I think I just put it in. Weird.
What were you saying, Kimmery?
Maddie, can you get your backpack put away?
You have 20 numbers you put in?
Yes.
Why am I only getting 16?
If you
Hold on.
if you go back to the quiz.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. On the quiz, I count 19.
Really?
I count 20.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Yeah, I count 20.
What?
Do you know what? Go back to your SPSS, where you would input the data, and we can read them off to you.
That is so weird. On my quiz, I count 19. Oh, hold on. There's 20. My screen was down low enough that I didn't get that.
We forgot the last
That's
one.
my problem. When I was inputting them in SPSF, my screen was down lower, so I missed the top few. Okay, let me update that. I was so confused there for a minute. That would probably make all the difference. I'm sorry, I've got a very unhappy little guy.
That's okay.
If you hear it, I'm sure.
You're right, it's 0.040.
Oh, I love it when we get a consensus, because until then it's always like, oh, no.
Someone tell me, remind me of the jingle.
Which jingle?
If the p-value is low...
Oh, then you reject the null.
Okay.
Yeah. P is low, reject the null.
Reject the null. Okay. So then 10 would be reject the null.
Okay.
Right?
Let me come back to here.
So what was 9 p-value?
The p-value is
Yeah.
0.040.
I just didn't type in the other 0.
9.
Wait, what was
zero?
the p-value?
0.040?
But we're supposed to round to the 3 decimal place?
Yeah, the next number after that is a 4.
Yeah.
So it would be 0.0404.
04. Yeah.
0.040. Okay.
That's
04.
And then for 10, we would reject the null. And then on 11, we just have a new set of numbers.
Okay.
Oh, good. Now I just got my others put in.
Okay.
So what did you guys get for 11?
I'm, I'm still typing.
Oh.
Let me just double check here. Is there 21 numbers in this, or 22 numbers?
21. No, 20.
Okay, so
Wait.
I'm getting 21 numbers.
Yeah, wait. 1, 2, 3, 4, 5, 6, 7, 8, 9,
there's
10,
21.
11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Yes.
Okay.
Okay.
Okay, so
Let me. Does the question say? Let's
What's
see.
the p-value?
for p-value got 0.000577956.
Oh.
Yeah.
Did you put the null hypothesis as 40?
Oh, that's what I haven't done yet.
Okay.
Okay, so the t-value I have is 0.006.
No, the p-value.
Oh, the p-value.
Yeah.
I've got 0.9952.
Yes. That's what I got.
Okay, so I'm so not. How do we do this? I put in all of the variables.
Okay.
Null hypothesis is 40.
Yep.
Oh, type of test, are we doing greater than?
No, it does not equal.
Does not,
Yeah.
not equal to. Okay, so now for p-value got 0.995270372.
So
I believe that's it.
0.995?
What was
Yep.
that?
Yes.
0.995.
Oh, awesome. Okay.
And then on 12, we fail to reject the null.
Yes. 0.992, right? That's what we just said? Just double
Wait,
check.
what?
Oh,
0.995.
0.995.
And then reject the null.
Fail to reject.
Oh, fail to reject.
Yeah.
So 11, 0.995. That's what I got. Is that what you guys got?
Yeah.
And fail to reject.
Yeah. And then for 13, this is really easy. We just move it from does not equal to less than. And then it will tell us the new p-value.
0.5023?
Yeah.
Okay.
That's
So
right.
It
So,
Wait, what number you guys got?
the mean is less than 40 is what it's asking, right?
Yes. So just switch the top part to less than. And then the p-value will come up
Yep.
with 0.5.
5. Yep, 0.502.
Yeah. So then it decreased from 0.9 to 0.5.
Yeah.
Wonderful.
But we still fail.
Where are you
Yeah.
putting the less than at?
So
You have to do it on the Excel.
Oh, you cannot do that on SPSS?
No, you can't do it on the SP. At least I haven't learned how to do it yet. It's very simple on the Excel because it gives you a drop down that you can move back. Can you still see my screen?
Yeah.
Yeah.
Right here. Right here, it gives you this drop down bar for the type of test if you want to do a not equal to like we did the last time, or if you want to do a greater than or a less than, and then it changes with each thing that you change, it changes the p-value down here.
Cool.
okay.
But for some reason, if they've taught us how to do that, I've forgotten how to do it, but I don't know that they do. I think there was something about how you had to go to here, and then you had to, did they say something about taking this right here and you have to divide it?
Yes,
By 2?
that's right. You have to divide it by 2. Yeah.
Yeah.
That's right. Okay. So
then, I mean, it ends up being about the same. I mean, whereas the Excel says it's 0.502. If we take the two-tailed sigma and divide it, it's 0.497. So it would round up to 0.5.
Okay.
Does
Okay.
anyone still have the first numbers, like the 98, 99.6, those numbers still in one of their
Yeah,
computers?
I believe so.
0.9.
Yeah, I do up here.
Okay. So could you tell me the confidence interval?
Yeah.
Confidence interval. Do you want the confidence interval of 99, 95, or 90
Yeah.
or 90? Which one do you need?
So when we typed in the information for the finding, we did like the mu of 98.6 and then typed in all the 9 numbers.
Mm-hmm.
The
You
confidence
still have that
interval
one up?
per question.
I do. But which confidence interval do you want? Do you want for 90%, for 95%, or 99%?
Oh, I don't know. Just put it at 95.
Okay, 95, the confidence interval, the lower is 97.7885, and the upper is 98.6515.
Okay, so the width, which one is wider? That would mean that 13 is wide. Oh! Oh, wait, I see what they're saying. Just kidding. I misread 15. I was like, what the? We have to put all that information back in? I see what's occurring.
Let's see here. Oh,
We just have to do this.
oh,
So what did you guys put for 13 then?
we put that it decreased.
Decreased. Okay, that's what I thought.
And then
'Cause
for, oh, good.
Sorry, what did you say, Manette?
I was saying for 14, did you guys get fail to reject the null
Yeah.
hypothesis?
Because it's still bigger than
Yeah.
0, 1. And then 15, I just double checked it and they're the same. It doesn't even move.
The confidence interval doesn't move between the two.
Mm-mm. It's exactly.
Oh, you know what? It wouldn't move because yeah, you're not asking. It doesn't change whether you say it's less than or equal to, right?
Right. Should we read through them, make sure everyone's on the same page?
Yes.
Okay. I'll start at number 3. So 3 is we assume that sigma is unknown.
Yeah.
4 is no. 5 is 1.5. X bar is 98.220 for number 6. Number 7 is 0.992. 8 is negative 1.843. 9 is 0.040.
Wait, what was 8?
Oh, negative 1.843.
Okay, that's what I got.
Okay. 10, reject the null. 11, 0.995. 12, fail to reject the null. 13, decrease. 14, fail to reject the null. And 15, they are the same.
Very good.
We feel good about that?
And what did you have for 9 for the p-value 0.040?
Yes.
Is that what you got?
Okay. Yeah.
Okay.
Oh wait, I got 0.0404.
Yeah, so, and that's correct. We just round up to the third decimal place.
Okay.
Yeah.
So that 4 just drops off.
Sweet.
Ready?
Yeah.
Yeah.
Yay! Let's see. Woo!
Yes.
Yay! Yeah. And that, ladies, is what success looks like.
Yes.
Thanks, guys.
Oh,
Woo!
thank you.
That's always my favorite.
I know, right? It really is. It really is.
You're like, I am a genius.
Yes, when we take 4 of us together, we are genius level.
It takes all 4 of us,
No kidding.
But I'll take it.
Awesome.
Yay! Yeah, I guess have a great weekend.
Yeah, you guys too. Bye.
Okay, see you Tuesday. Bye.
Yep. See ya.